Hello students, today we are going to learn about the cathode ray tube working principle. This is a display device of computer and comes under the scope of computer graphics. So this is a hardware device. Okay, so we learn the working principle. So coming to the topic, see, you might be knowing about laser light, the keychain laser light. You can see this is a laser light and this is a screen. Just to make you understand, I am taking this example. So this laser light is pointing at a point of screen. This is phosphor screen. So in case you start shaking laser light like this, you will see that point is going to and fro according to that shake. Okay, but in case you shake it in extremely fast fashion, okay, means this to and fro motion is more than 16 cycles per second. In 1 second, more than 16 times you are shaking it to and fro, then you will see a straight line on the screen, not a dot moving. You know why? Because if an image passes away in front of human eyes in less than 1 by 16 second, then the brain will be incapable of the presence and absence of that image. Okay, so in case in a sufficiently fast manner, if you are shaking the laser light, and I told you more than 16 cycles per second, then you will see a straight line instead of a dot moving. Okay, now let's take the front of the screen. Okay, so you can see that this is the front of the screen. Okay, so you can see this is a rectangle. So you can show a rectangle on the screen by the help of laser light. Laser light is behind the screen. You can go like this, that this is the point of laser light on the screen. You can see this is moving like this, it is moving. So in case it is moving in a sufficiently fast fashion, you might be able to see a faint straight line. Okay, so like this it is moving, and ultimately like this all the points and covering all the points like this. And in a sufficiently fast fashion, if it is moving, then first you will see a blinking rectangle. Ultimately, if it is super fast, then you will see a stationary rectangle. So like this way you can develop an image by the help of a laser pointer. Okay, now coming to the topic, that how the cathode ray tube works. Okay, this is the principle I am showing. It consists of a cathode and an anode. You can see a circular disc type anode which has a hole at the center, and this is the cathode. Okay, so what happens, we apply high voltage between cathode and anode. Okay, high voltage, higher than 20,000 or 50,000 volt, like this. So this much high voltage is applied between cathode and anode. Okay, and the cathode is kept with negative terminal, means negative charge is applied to the cathode, and the anode is kept positive. So what will happen, due to this high voltage, the electron starts emanating out from the cathode and will move toward anode. You can see stream of electrons are coming out. This gray colored line is showing the stream of electrons, and ultimately through this hole a fine beam of electron will come out. It will hit this anode, but you can see that there is a hole at the center, that is called as focusing hole. A fine beam of electron will leak out. So this is what called as cathode ray. Okay, now you can see a heating coil around this cathode. The reason being, by the help of heating coil, in case we are heating the cathode, then it enhances, it accelerates this process of emanation of cathode rays. Okay, now when these cathode rays are going, okay, and this is the screen, so in between there is a deflector mechanism. Okay, deflector mechanism means the plates, you can see negative plate, positive plate, top is positive, bottom is negative, and as you can see a plate over the screen positive and inside the screen negative, like this. So what it does, this deflector system is capable of deflecting the path of cathode ray before reaching the screen. You can learn by this example. See, if there is a negative tap, you can see, and water is coming out which is negatively charged. In case positively charged rod, a solid rod which is positively charged, is brought closer to that flowing water, the flow of water will be deflected, path is deflected. In default, the water will fall straightly in downward direction. In case we are doing this activity, means positive charge is brought to negatively charged flowing water, so the path is deflected. Like same here, when the cathode ray will pass through, since positive charge will attract the negative charge cathode ray, because the cathode rays are negatively charged, it is emanating from negative electrode cathode. Okay, so it will be attracted toward the positive plate. In case inside screen plate becomes positive and outside plate is negative, then the ray will be deflected inside. Similarly, this top and bottom plate, in case top plate is positive, then the cathode will be deflected toward the top, and in case bottom plate is positive, the cathode will be deflected toward the bottom. Okay, so these four plates can control the point where the cathode ray will fall on the screen. Okay, so the image is formed on the screen by movement of cathode ray to and fro and up and down. Okay, this is called as rastering. Like this, the cathode ray travels like this. You can see horizontal and then coming back like this in a zigzag fashion. It goes to the bottom, ultimately reach the last point, and then again coming back. Again in a zigzag fashion, it moves up to the bottom and then last point and then again coming to the back. And this rastering action means to and fro and up and down can happen with a frequency of 60 cycles per second. It means this entire cycle completes in 1 by 60th of the second. And this zigzag fashion in horizontal direction is called as horizontal rastering. And then after reaching the end point coming to the initial point, it is called as vertical rastering. Okay, so you can see an image of white triangle is formed by this section. How? I will tell you. See, the image formed on the screen depends on the intensity of the beam and the rastering which is developed by this deflector mechanism. Okay, so what happens that when the rastering is occurring, then wherever there are white points of triangle, the cathode rays intensity is higher at this point, at this point, at this point, at this point, and rest of the point you can see the cathode ray is gray. Actually, the intensity is lower. So on a gray background, there is white triangle formed. Okay. And one thing more, that this entire mechanism is kept inside vacuum. Okay, not in open air. So cathode rays tube is always in vacuum. In vacuum, this entire process happens. So at last, the 2 points which we can conclude are the voltage between cathode and anode controls the intensity of the beam. Greater the voltage between cathode and anode, greater the intensity of the beam, and the voltage and polarity plus minus minus plus among the deflector plates control the position of cathode ray on the screen. So the rastering is rendered by these deflector mechanism, horizontal and vertical rastering, and intensity is managed by the power applied or voltage applied between cathode and anode of the cathode ray tube. So hope by this small lecture you would have understood the working of cathode ray tube. Thank you.